Alright, in continuation with the ND2 past question, this is question number 2. We are told, given that y is equal to exponential minus 2x, show that the third derivative of y minus the second derivative of y minus 5 times the derivative of y plus 2y is equal to 0. Okay, so this question is just saying follow the relation that was given, if I would say it that way. So it means we need to find dy dx, because you can see dy dx there. So we get dy on dx, and we get the second derivative, that's d squared y dx squared, and we also get the third derivative. So our first task is to differentiate y 3 times. So this is the solution of the a part. So we have y is equal to exponential minus 2x. So I think I'll just give space for my calculations. Now, what is dy dx? It's because that's the first derivative. What is dy dx? Dy dx, anytime you have an exponential function, just differentiate the power there. Okay, if I want to put it that way, differentiate the power. So if you differentiate minus 2x, you get minus 2, and then use it and multiply. So you just have minus 2 exponential minus 2x. So this is dy dx. Now, the second derivative simply means differentiate your answer, differentiate your first derivative again. So again, you see that we have minus 2x in the power again. So if you differentiate minus 2x, you're going to get minus 2, and then this is going to be more of minus 2 multiplied by the whole thing. Okay, I'm just going to write that in full. Okay, so if you now have minus 2 times minus 2, you're going to get plus 4. Okay, so I can now clean the whole of this. Now you know how I'm getting the 4. So if we differentiate this, we're now going to get 4 exponential minus 2x. Good. And then the third derivative is d cube y dx cube. Differentiating this again, differentiate minus 2x, you're going to get minus 2. Then minus 2 times 4 is going to give you minus 8 exponential minus 2x. We have the whole thing. Now we want to show that from the question, we're asked to show that d cube y dx cube minus d squared y dx squared minus 5 dy on dx plus 2y is equal to 0. Good. So let's start by just replacing. What's the third derivative of y? From what we have differentiated here, you can see that clearly the third derivative of y we have as where is it? Yeah, look at it, minus 8 exponential minus 2x. So we're just going to replace, we're just replacing. So I'm going to replace it with minus 8 exponential minus 2x minus, what is the second derivative? D squared y dx squared. Second derivative is clearly 4 exponential minus 2x. So I'm going to replace it with 4 exponential minus 2x, and then minus, what has happened to my minus 5? So please let me just rewrite this, please. This is minus 5 dy on dx. I don't know why it's floating. Minus 5 dy on dx. So first of all, you can see that this minus will multiply this minus, making it plus. So instead of wasting my time, let me just change the minus to plus. Okay, so I'm going to come here and just put plus, and I'm just going to have 5 times dy on dx. But what is dy on dx? What is dy on dx? dy on dx is clearly minus 2 exponential minus 2x. So I'm going to put it. So I'm going to have times minus 2 exponential minus 2x, and then finally plus 2 times y. What is y? What is y? from the original question, y is exponential minus 2x. So I'm going to replace. I think that's the last replacement. Exponential minus 2x. I'm hoping that this is equal to 0. If it's equal to 0, I have shown that, because we asked to show that. So, okay. So we have minus 8 exponential minus 2x minus 4. Minus 8 minus 4, that should be minus 12 exponential minus 2x. Now this is plus 5 multiplying minus 2. So plus minus is minus, and then 5 times 2 is 10 exponential minus 2x. Good. And then 2 times that, we have plus 2 exponential minus 2x. All right, so this is, we want to show that this is equal to 0. Okay, so you can clearly see that this will not be equal to 0. Okay, so I think the question, I think there might be a problem somewhere, because assuming this was plus, if I change this to plus, this is going to be 10 plus 2, that's 12, and then minus 12 plus 12 will be equal to 0. So it means that this question is actually wrong. Maybe a typographical error. So this question will be correct if this is plus, okay? Because if this is plus, this minus times this plus will be minus. So let's begin to rectify. If it's minus, so I'm now going to have, so I had changed this to minus before, right? Okay, I changed it to plus, which will also remain minus. So I'm going to change this plus to minus. So this would be minus. Okay, and minus 5 times minus 2 will now be plus, and then we're going to have minus 12 exponential minus 2x plus 12 exponential minus 2x, and that is definitely 0. So please, if you have the past question, you may do well to correct the question. So instead of this to be minus, because the question was it as minus, you can change it to plus. You can also ask around, okay, just to verify what I'm saying. But if I were to leave this as minus, it wouldn't be so. And since the question says we should show that, it means that the question is suggesting the fact that that should be equal to 0. The whole expression on the left should be equal to 0. So please. All right, so I think that's it. So let's go to the B part. Look at the B part. We are asked to, okay, I'll just copy it and then we'll solve it below. So look at the big question. We're asked to find the derivative of y equal to 3 plus 5s squared raised to power 30. Now, it would be terrible to try to expand. Okay, so that's why you need to know your basic differentiation method. We have power rule, we have the first principles, we have chain rule, we have U substitution. Clearly, we are going to use U substitution because this is a function of a function, because see that x is inside the bracket and we're also raising it to the power of 30. So if you don't know the U substitution method, this is how we do it. The term inside the bracket say that let our U be equal to that stuff, which is 3 plus 5x raised to power 4. This is what U is going to be, and then we're going to differentiate. We're going to differentiate the U with respect to S. Alright, so when we differentiate U with respect to S, what are we going to get? If you differentiate 3 is a constant, it's going to be 0. If you differentiate 5s squared, remember, power rule now, it will be 4. That's the power. 4 times 5, which is 20x, 4 minus 1, which is 3. Good. And then we also have y equals, since we said that 3 plus 5 x raised to power 4, we have said that let it be U. So that means the new equation is going to be y is equal to U raised to power 30. It makes sense. And then we can now differentiate y with respect to U. Okay, differentiating with respect to U, we're going to have 30 will drop down, U 30 minus 1 is 29. Good. So this applying chain rule, we're going to have that since we're looking for dy on dx, because that's the question, we have to find the derivative, which is just dy on dx. So dy on dx is clearly dy on du multiplied by du on dx, because if du cancel du, we just have dy dx yet again. So this is going to be equal to, what is dy on du? Dy on du is 30u raised to power 29 multiplied by, what is du on dx? That's 20s cube. All right, this is what we have. So if you multiply, what are you going to get? 3 times 2 is 6. Add the 2 zeros. So we have 600 s cube u raised to power 29. This is not the final answer, right? We just have to put back the value of u. So we can actually say that dy on dx is equal to 600 s cube. What was u? Remember, u is 3 plus 5x squared. So we're going to open a bracket and say 3 plus 5x raised to power 4 raised to power what? 29.